This is Algebra 2 with trig, 1D.1b. We're going to solve system of equations algebraically. So this first one that we're going to work on is something that you've probably learned in the past. It's typically the more advanced type that we call elimination. So we're going to solve this first one. When we look at these two equations, we are noticing that these would make a line. These are linear equations. They're to the first power. There are no squares. So if we're going to use elimination, we can use that for two linear equations. We can use elimination. So we like to add our x's together. But in this case, when we add the x's together, we're getting 4 x's. And if we add the y's together, we get 6 y. We need one of the coefficients to cross each other out. You often have a choice. But if we multiply through every term by a number, we're not changing the value of the equation. We're just making it look different. So we're going to multiply this first equation by -3. What would -3 do for us? -3 would give us -3x. Then we'd also have to multiply and do -3 times 4, which is -12y, and -3 times 1, which is -3. So we have changed the problem that can be reduced, and it would reduce right back to this. It's the same equation. But we're going to add these two equations together now. By adding the x's together, they completely cross off, and I'm left with -10y. And -12 minus 3 is -15. So to get my y by itself, I divide by -10. So I have a positive 15 over a positive 10, because a negative over a negative is a positive. I can reduce these by 5, and I get 3 halves. That's a little scary. We're getting fractions? But yeah, I guess you're getting fractions. So here we're going to say x plus 4 times 3 halves equals 1. We're going to substitute in this value into either one of the original equations. I chose to plug it into this equation because I thought it was a little bit easier. But how am I going to multiply 4 times 3 halves? So if you want to write a fraction times a fraction, you put the 4 over 1. 4 times 3 is 12. It's not equals, but it's plus. X plus 12 over 2, which is actually 6. And you subtract it over to get -5. 1 minus 6 is -5. So my solution where these two graphs are going to cross is at -5, 3 halves. We could test them to see if that's going to work. You could test it. So if you take your x value plus your y value, we should get the answer of 1. 12 over 2 Alright, this is not working. 1 second. What's going on? Yes, it's 12 over 2, which is 6. and that is 1 equals 1. Check. It worked. Now we can also check it into the second equation. You should check it into both equations. If you ever want to know if you did your math right, you can always check your solutions. And these are good examples because I'm working with a fraction. This is negative 15. This is 6 over 2, which is 3. Negative 15 plus 3 is not negative 18. It's negative 12. Check. It works. So my solution of negative 5, 3/2 gets plugged back into both equations, and it makes both equations true. So I know that that is a solution. Now we're going to come down and we're going to work with a circle. When you're working with a circle, elimination doesn't work as well. So we're going to have to try something different. We're going to use substitution. That's going to work a lot better in these situations. So x squared plus, if my y value is 6, I'm going to plug a 6 in for my y. I get my x squared plus 3 squared equals 25. So x squared plus 9 equals 25. I subtract my 9 across. I get x squared equals 16. And I take the square root of 16. And I get plus or minus 4. That's where some people make a mistake on their quizzes. They don't take the square root of 4 as a plus or minus. It's not the square root of 4. It's the square root of 16, which is plus or minus 4. Now, I know this implies that I have 4, comma, plug it back in, but this is straight up. It's just 6. And negative 4 should give me 6. You could have plugged it into the other equation if you wished, rather than just taking that one, just to show you what it might look like. You can do the math. 4 squared plus y minus 3. That's 16 plus y minus 3. Minus the 16 across gives me 9. Take the square root of both sides. Plus or minus 3. So I get y equals 3 plus 3. And I get y equals 3 minus 3. I get 6 and 0. Alright, so what happened there is I plugged in the 4. I didn't have to do all this math. I plugged in the 4 and solved for y. I needed to plug in the 4 and plug in my 6. If I would have plugged in the 4 and plugged in the 6, we saw that that worked. But when I plug in the 4 and plug in the 6, we're testing our point. That's 25 equals 25. So testing our point, that worked out great. If we were trying to figure out our value, we saw that we got a 6 value when we plugged in the 4. All right. How about this one? What do you suspect we might do?
I'm thinking that we substitute 2x into y. So it's 2x squared equals y, and then divide 2 by both sides. You get x squared equals 4. Square root both sides, you get x equals 4.
Okay, we know what the y value is, and y being squared means we're going to put its value in place of the y, and we're going to square it. When you square a monomial, that's when we can distribute. We can't distribute into a binomial, but you can distribute into a monomial. Yes, you could simplify this, but one thing you have to do, you have to bring the b value to the left, simplified or not. I'll just factor out my 4x, and I can use the zero product property. And I got my two answers. When I plug in 0 for x, I get 0 for y. When I plug in 2 for x, I get 4 for y. Those are my two solutions. Just to explain where my two solutions came from, I took my 0 and my 2. I have a 0 and I have a 2. And I can plug it into either one of the original equations. So when I plug in 0 in for the x, I get an answer of 0. So I'm saying my answer is 0, 0. Then when I try my other point of 2 into that equation, I get 4. So when my x is 2, I get 4. I could have plugged it into here, plugged in my 2, that is 16, take the square root of that, would give me 4. Alright, we'll come down here and try this one. Try to make a determination of what you're going to do. How do you start these problems? How are you going to start it? What needs to be done? Into the y. This is what y equals. So I'm going to plug my negative 3x plus 10 into the y that is being squared. Plus 10. Unfortunately, I cannot distribute into a binomial. I have to write this twice. And then I'm going to FOIL this together, and this makes 9x squared, negative 30x, negative 30x, plus 100 equals 10. This makes 10x squared. I saw on your quiz that people had troubles with like terms. They were just putting all x's together. You can't do that. You can only put the x squareds together. And then you can only put the x's together. Minus the 10 across to give me positive 90. I notice that all of these are divisible by 10. We don't really need the 10. We could divide by 10. But we're going to factor this apart, which is x minus 3 and x minus 3. It happens to be a perfect square trinomial. So my value is 3. When I get x equals 3, I'm going to plug that back into my original equation. So I get y equals negative 3 times 3 plus 10. Y equals negative 9 plus 10, which is 1. So when I plug in 3 to one of my equations, I get 1. So 3 comma 1 is my solution. They should only cross at one spot.
How'd you get them 90 again? The 100 and did what?
Doing our math, we're going to subtract the 10 to the 100 to make the 90.
Oh, yeah.
Then I divided out the 10. Then I factored set our binomial to 0. I didn't need to do it twice because it was the same binomial. And I got 3. Last one over here. So this is y equals 3x plus 6. You need to write your equation with one of your variables written by itself. I'm getting the y by itself. This one I think gets a little messy looking. We have to write a binomial squared. We have to write it twice. So now we're going to have to FOIL. So we have 8x plus 3 times 3 is 9x squared, positive 18x, positive 18x, and 36, plus the other 24. So you notice I only have one set of x squares. I only have the 9x squared. Then I have 18 and 18, which is 36. So that gives me 44 x's. That gives me 60 constant numbers. So maybe it's factorable, but I don't want to mess with the factors. So let's go through our quadratic formula, because completing the square doesn't look nice either. So negative b plus or minus b squared minus 4ac all over 2a. Now this is interesting. This is 44 squared. And this is going to be minus something pretty darn big. There's a pretty good chance this is negative inside the radical. If it's negative inside the radical, then we know that there's no real solutions. There are no values that this is going to cross at. So if you take your calculator and you do your discriminant, which was 44 squared minus 4 times a times c, you get a negative 224. So in terms of showing work, we could just stop right there. We don't need to play the imaginary number game. We can just say no solutions. Good job. Okay.
You go ahead.
Good attempts. See how you're writing it twice?
Yeah.
You could mathematically do that.
Okay.
But I'm sorry. That's painful.
Yeah, it is a lot.
Mathematically, that should be doable. But what is your like terms? What are your like terms? What could we do from there?
So I've got a test to make up. Could I just give you these so I can go take the test? I've got a history test to make up during lunch.
Sure.
Okay. I apologize. I'd rather flip through them instead of make you do it. I just said that.
So you have another one?
Yeah,
Okay. 1C.1 to 1C.3.
Yeah.
Sound right? So this has a non-calculator side and a calculator side.
Let's do the calculator portion. I don't know if I should do it now or if I should do it after school.
You're welcome to do it after school.
Can I just do that?
I
Or
will-
give me the brain break or
I
something?
will be in
The
the
swim.
pool.
Okay,
Okay?
that's fine.
I'll have to figure out how to get so many of you guys settled, but it'll work.
Okay.
Yes, you too.